Okay, so yep, we're recording. Just doing a fairly quick video. I was going to make this a two-topic video, but instead I'm just going to do one topic, which I think is a pretty important topic, and frankly could be a very easy topic for you to get some points on different quizzes and tests and FSAs and SATs. So I'm going to go to Smart Notebook. And we're just going to go over when you have a system of equations, what's the best method to use for that system of equations? And we're going to kind of go over what your visual clues are to be able to do that. And then sometimes it's not a visual clue, it's just something that you have to understand when you get kind of toward the actual end of the problem and figuring out what the solution is. So there's three possible methods. Oh, well, first of all, a system of equations just means you have more than one equation. We're really only going to deal with two equations in this class. And this is algebra 1A, 1B. So each of these is an example. So here is one system of equations. This is one system of equations. This graph down here is one system of equations, different from all of the other ones that you're looking at. I've just already graphed the lines instead of giving you an actual equation that you would then need to graph. Again, this is a system of equations. This is a system of equations. This is a system of equations. This is one. This is one. This is one. So what are our clues to know how to solve it? Well, the first thing you want to think is, can I graph it? I think that's always the process you should go through. You might want to think, can I use substitution? Because in all honesty, substitution is the best way to do it if you can, because it always gives you an exact solution. I just know some of you like to graph things better. You kind of got good at that. So, well, your hint about graphing is you're kind of looking for equations that look like these two equations. Y is all by itself. You have the format of y equals mx plus b, which hopefully looks familiar to you by now. You did it in 8th grade, and we've done it a lot this year, whatever year this is, meaning that this is an old video for some of you. So I know immediately, well, this end value right here, I keep hitting the mouse, this end value rise over run. So whenever I see that format, I know I can graph a line pretty quickly. So that's why seeing a system of equations where both equations are in that format gets me thinking, okay, I could probably graph this one and hopefully get a pretty quick solution. And I'll tell you why I said hopefully in a second. So now though, let's look at a different type. So here we have a second system of equations right here. Well, we do have one equation that's in that y equals mx plus b format. Second equation, not so much, unfortunately. Although we did learn how to graph standard form equations. This is where you do the whole plug in 0 for one variable and solve for the other variable, or we called it cover up and solve, cover up and solve. So if you like that way, and if you feel pretty comfortable with that, you'd be able to graph this one still pretty quickly. The values of x and y will come out as nice round integers. It's not too difficult to graph. And then you can see where the two lines cross, and again, hopefully get a solution. Why do I keep saying hopefully? Well, here's why. Sometimes when you graph two lines, it's going to come out and they're gonna cross. Sometimes they won't cross. We're not getting any of that. We're not going to get into that in this video. Sometimes though, when they cross nice and neatly right at the corner of two squares. So what this means is when I look at that, I can pretty comfortably say that that solution is probably supposed to be -1, 1. Because where they cross, so this point right here, is right at the -1, excuse me, on the x-axis, and it's right at the +1. That didn't come out very well. It's right at the +1 on the y-axis. So that means the solution is just where they cross. I just put the coordinate for that particular point where they cross. What is the x value and the y value? So that means graphing was probably a good solution, a good way to solve that one. Unfortunately, that's not always the case, as you'll see. I'm going to move over to substitution when you use substitution, and you'll see that sometimes when you have a graph, you can't solve it using graphing. You have to use substitution to get an exact answer. Substitution can be used pretty much the same times that graphing can. There's just one additional time where it can be, actually two additional situations where it can be used. So if you really like substitution, I would just say use substitution all the time, unless it tells you have to graph it. Again, we have y equals mx plus b, y equals mx plus b. The key to substitution, excuse me, the key to substitution is as long as you have at least one of the variables isolated, it's all by itself. So if you'll notice, we have y all by itself in both of those equations. Down in this particular system of equations, we also have y all by itself. Down here, we have x all by itself, but we still have one of the variables all by itself. That's when it's really easy to use substitution. So I could graph these right here like I did in the graphing examples. This one, though, not really. That one's not really one that is set up to graph because we have x all by itself instead of y. So it's not in that y equals mx plus b format. So this last one, you would definitely want to use substitution on that one. And then, like I said, substitution, if you really like doing the math process as opposed to graphing, it will always come out with an exact answer. So any of these would be easy to do during substitution. The last situation where you really can't use graphing, so you'd have to use substitution, is this fourth. So this is a fourth system of equations down here. I've just graphed it instead of giving you equations. If you'll notice now, when the two lines cross, which is that's my solution. I didn't go over this. I'll do it real quickly. Every point on the blue line. Remember, a line is just a bunch of points. They get closer and closer together. They follow a pattern, so that's why they look straight. Every point on that blue line is a solution to whatever the equation is for that blue line. Every point on the green line is a solution to whatever the equation is for the green line. That means those points would make the left side equal the right side. Well, the one point where they cross then must be a solution to both equations. So that's why the point where the two lines cross is our solution to the system of equations. Well, the problem with this one, I'm going to zoom back in. Problem with this one is when they cross, if you'll notice, they're not crossing at a really nice, neat point. They're not crossing right on an integer. So for example, here on the x-axis, they cross at like probably about, that was not a very good job. I wish I could zoom in more. Oh wait, maybe I can zoom in more on this with the computer screen. Let me see. Oops. Oh, I don't think so. I don't think it's going to let me do this. Whoop, I definitely don't want to do that. Yeah, it looks like I cannot, yeah, I can't zoom in anymore. So this point right here is, try that again. Nope, I don't like that. We'll say about right there, and then about right there on the y-axis. So as you can see, the point on the x-axis is kind of in between 0 and -1. The point on the y-axis is in between 0 and +1. So I can't really tell exactly where they are. So all I could do is guess. So for my x value, I might say it's -0.7. And then for my y value, that actually looks pretty close to halfway. So I might say it's 0.5. So again, graphing is not a good way to solve those because they're not falling right on integers. So you would want to do substitution, and substitution would give you an exact answer for that. So unfortunately, you wouldn't always know that until the end of the problem, but normally they'll kind of tell you when to use substitution if it's not going to come out exactly on integers if you graph it. So, well, come on, there we go. So last situation, when do we use elimination? Or it's also called solving algebraically, as you see up there. Well, you pretty much use this whenever you can't use the other two. If you'll notice, there's no y equals mx plus b in any of these equations. So that kind of eliminates trying to graph stuff. I mean, some of these we could still graph, like these are all in standard form. So we could still do the cover up and solve, or the plug in 0 and solve for the other variable. So we could do that with all of these and graph them. Again, that's not our favorite way to graph those, so we wouldn't necessarily be thinking to do that with these equations. In addition to that, if you'll notice, another key that we've kind of talked about, the variables and numbers all line up nice and neat. All the x's are in a column, the y's are in a column, the threes are, or the numbers are in a column. Same way here. X's, y's, numbers, x's, y's, numbers. That's a huge, huge hint that you want to use elimination, because they're putting it in that format for you so that it's kind of easy for you to solve it out. Another example or another hint, if you'll notice, we have a term here that is negative 3y, and then the term below it is the exact opposite. It's positive 3y. So that would, elimination would have those cancel out really easily when you added the two equations together. So pretty much if you see the columns, though, I would say that's your best hint to use elimination. And then you don't have any variable isolated, so substitution is not a good method. The only other possible method would be graphing, and we normally like to do graphing when we see equations in that format, y equals mx plus b. Although sometimes you will have to do it when it's in the standard format, like all of these are on the eliminations. So anyway, that's the overview of when to use each different type of solving. And we'll actually do other videos where we solve out, or we already have other videos where you solve out using each different type of method.